put this at least somewhat in context. First off, we are, of course, finding, in fact, I walked by the Kepler booth on the way over here, and that's going to be a mission that will crank out a lot of discoveries of planets around other stars. But for the last 15 years, we've been finding extrasolar planetary systems around other stars. And so I can actually highlight our catalog of extrasolar planets. Well, this isn't exactly what I wanted, but oh, here we are. So the little blue crosshairs, 3D crosshairs, each one is centered on a star, and that star shows some evidence for a planet in orbit around it, or maybe multiple planets. So we now know more than 400 planets around other stars, and so what we're doing here is we're highlighting the other stars that have evidence for planets around them. Now these are all relatively close to home, but to give a sense, since we looked at the Pioneer and Voyager spacecraft, those are our fastest sort of physical objects that we sent out into space. But of course we've also been emitting radiation out into space in the form of radio waves well, if you go back to Marconi, those signals were not strong enough to escape the ionosphere of the Earth. So you have to go back to the invention of radar and television in the late 30s and early 40s. So if you want to think about our sort of electromagnetic footprint in space, then what you need to do is look at the what we like to call our radiosphere. So it's a little hard to tell here, but this is actually a sphere. This is a sphere of radius 70 light years. So radio waves, of course, are a form of light. They're traveling at the speed of light. So radar and television signals that have escaped the ionosphere of the Earth have traveled at most about 70 light years from home. Earth. I wouldn't detect anything because the light simply hasn't had enough time to reach my radio telescope. So this sphere, this radiosphere, represents sort of our electromagnetic footprint in the universe. This is as far as our radio signals have traveled out, that some signal of intelligent life. You can think of it as, in terms of light travel time, it's sort of like the technological history of our planet in terms of light travel time, with 70 light years in radius. So let's now put that. I'm going to go ahead and remove our extra. I mean, right now we're seeing the stars that are depicted are about 100,000 stars from the Hipparchus catalog, which has the most accurate distances to the bulk of stars nearby. But let's go ahead and pull away now and take a look at a representation of our Milky Way galaxy. So this sort of haziness you see in front of us, we're now passing through the band, the plane of the Milky Way galaxy. What we see in our night sky as the band of the Milky Way, that hazy band that you don't see from San Francisco, or probably even from here. You've got to get out a ways to see a dark sky and be able to see the band of the Milky Way. So called the Milky Way because Greeks saw it as spilled milk from Hera's breast scattered across the sky, which is no longer the prevailing opinion. Instead, of course, we realize that the billions of stars in our galaxy are kind of blur together along this band in the sky because our galaxy is flat. So we're now looking at, pull away a little farther. Our Milky Way galaxy, about several hundred billion stars in the galaxy. There, of course, is our radiosphere, now just a few pixels in size. And to put this in context, the center of the Milky Way is about 30,000 light years from Earth. So what were humans doing 30,000 years ago? Well, we were painting the interior of caves. So now, as we talk about light travel time, it's not just a pausing conversation like the distance to the moon, or a quick lunch like the distance to the sun in light travel time, or a good night's sleep across the solar system, or a high school or college education to the nearest star. Instead, it's comparable to the history of our species on the planet. And in fact, the diameter of the Milky Way galaxy is about 100,000 light years, which is about how long Homo sapiens sapiens has been on the planet.